In this video, I will show you a program for hashing that is unique using linear probing. So we'll write a C language program for linear probing. I'll call the project name as hashing and the language is C language. Let us create a project. For implementing hashing, we need an array for hash table. So I'll call an array as ht of type integer and I will take an array of size just 10. I'll limit the hash table size as 10. Then as the size is 10, so on the top I will use hash define for giving the size as 10. Now for inserting or searching in this hash table, I need the function. So first function I will implement, that is insert. Insert, it should take a array as hash table. So I'll just give it as h. And next thing is key. And the size is already mentioned as a constant, symbolic constant, that is size 10. So first of all, I will write on a insert function. So for that, function name is void insert, and it will take a hash table for inserting an element and also a key to be inserted. Now this function needs a index using hash function. So I will write a hash function. Hash function will take a key and returns index. So index is key mod size. So key mod size. Then this insert function should call that hash function and get the index of an element. So I will declare a variable index and call hash by passing a key. Now if that index is already occupied, then we should find the next free index. So first of all, I will check whether that index is free or not. If hash table of index is not equal to 0, it means it's already occupied. Then I need another new index where I should insert an element. So for that, I will call next function, that is probe. So it will find out next free space. So to this function, I'll send a hash table as well as the key to be inserted. So let us write one more function called probe, which will linearly check and find out a next free space, that is using linear probing. So function name is probe and it takes a hash table, array as well as key. Now again here, let it call hash function. Hash function will give the hash code for the key, that is index for the key. Now using a loop, I should find out a next free space. So for that, I will declare a variable I, which will be incrementing until a free space is found. So while inside a hash table, index plus I should perform mod once again, that is mod size. And until this is not equal to 0, I should go on incrementing I. And once a free space with value 0 is found, let us return index plus I mod size. So this is the free space for inserting an element. That's it. So this probe will return a new free index where a key value can be inserted. So at that place, we will insert an element in a hash table. So h of index assign key. So this is an insert function. Let us first try this insert function and check it. So here I will insert few keys. Insert 12. They should be inserted at index 2. I will also pass hash table ht and 12 is inserted. Then insert hash table 25. Then I'll insert one more value, that is hash table 35. Let us see where it will be inserted. And I will also insert one more value, that is hash table 26. Now here I'll put a breakpoint and I will run the program. You can watch in the debug area that no value is inserted, hash table is empty. Then if I continue debugging, now 12 is inserted at index 2 inside the debug area, you can see. Then next is 25 is inserted at index 5. The next 35, there was no free space, so it is inserted at next free space, that is 6. Now 26 should come here, but there is a collision, so 26 should be inserted at next free space. Yes, 26 is inserted at next free space. So that's it. So as the hash table size is 10, so I should not insert more than 5 values. So I'll stop here. I have already inserted 4 elements. So insert is inserting the elements. Now let us perform search or lookup. So I will call it as search. So search should give me an index. So it needs hash table, array, and a key to be inserted. Now first of all, it should get the index from hash table. So hash function, it should pass a key to get the index. Then while, so as this is linear probing, it should check whether the value is present or not, the key value is present at that index or not. If not, it should perform linear probing. So using while loop, I will do that. So for that, I will take a variable I, which is initialized to 0. Now while until the key is found, we will search for it. So inside the hash table, we will take the index plus I mod size. So this is the hash function for linear probing, and as long as that is not equal to key, we will continue searching and we will be incrementing I. And once it is found, we will return index plus I mod size. This I should put it inside brackets. Yes. So this will find out an element by performing linear probing. This loop is for linear probing. I already have a function for probe, but that probe function is for insertion purpose. I am using it. Now for searching also I should have different probe, because this probe function is looking for free space, and for searching it needs to check for key value. Now let us try for search function and check. So here I will directly print the result sent by search function, and here I will say key found at so and so index. So I'll use /n and call search, and I want to search for key 35. So 35 is inserted at 26. So 35 is inserted at index 6. It should return index 6. Let us run the program. Oh, search is taking too few parameters. I should pass hash table also. Yes, key found at index 6. So that's all. This is a simple C language program for hash table, and this is for linear probing. Now I'll give you an idea here, just a hint, so that you can implement quadratic probing. So instead of just I, here you have to write I into I. So this place I into I, this will be a quadratic probing. And wherever you are using I along with index, write I into I, that is I multiplied by I. So here also you can write I into I. So this will become a quadratic probing. So that's all in this video. This is a simple implementation of hash function of size 10 by using linear probing.